So we've gone through a few different ways of solving systems of equations, and this is a presentation of the final one known as Cramer's rule. Let's kind of review where we've been. We started off when we solved system of equations for the first time by graphing. And remember, when we graphed a solved system of equations, what we did is we graphed both equations in whatever form we wanted to. And once we did that, we found the point at which the two graphs overlapped, and that was the solution to the system of equations. The points where the x and the y values made both equations true at the same time, where I would make the left side of the equal sign be equal to the same thing as the right side of the equal sign. Then where we went to substitution and elimination method. Substitution and elimination were a lot more involved with actual mathematics, a lot of calculation, but they did the same thing. The difference between the two, if you remember though, graphing was not very precise. It was limited by usually whole numbers. If it didn't go through an even grid marker, it was very difficult, and if our neatness didn't match up to where we needed to be, it was also rather difficult. Substitution elimination took that away, but the problem is it requires a lot of calculation. Cramer's rule requires a lot of calculation too, but it's a different type of calculation. A lot of what you're going to be doing here is not so much solving an equation, but just multiplying and subtracting, which makes life a lot easier. So let's go ahead and take a look at the how-to here. That's the first thing to describe, how to solve with Cramer's rule. So first thing you're going to do is you're going to line up the equations in order with the x terms, the y terms, the equal signs, and then the constants. So that means you want all these written in standard form. And we've talked about standard form before. That's one of the very powerful ways we can talk about graphing a line. So standard form is not necessarily all that surprising to us. If you recall, when we did elimination method, a lot of our things were written in standard form. Then what you're going to do is you're going to set up two fractions, one for finding x and one for finding y, and you're going to put 2 by 2 matrices in both the numerator and the denominator. Now that's a new concept for you. A matrix is simply an array of numbers. What am I talking about? Well, it's basically 4 numbers written inside of a giant chunk of brackets. That's all it is. It represents numbers that we're going to see inside the system of equations. They're going to be fractional, so there's going to be a matrix on the top and the bottom of each, because that's the only way we could have a fraction. Once you do that, you're going to put the matrix of coefficients, which are the numbers in front of the variables, in both denominators in the same order they appear in the problem, and including the signs when we do that. Then in the numerators, for x, we're going to lift up the right row. For y, lift up the left row from the denominator into that numerator. In the remaining blank spots, we're going to fill in the constants in the order they appear with their signs. The constants, if we do that right, are what we're going to have after the equal sign, which we're going to have to because standard form is a requirement. Then we're going to take and find the determinant of the matrices. And to find the determinant, all you're going to do is multiply down the main diagonal, then multiply down the backwards diagonal, and subtract the results. And then you'll simplify your fractions to find x and y. Now, if you're totally lost, don't worry. There's a lot of new concepts here. We'll go through this and you'll see it's actually pretty nice. It's a lot different than what we've done with substitution and elimination. It doesn't require nearly the calculation procedures that it does with substitution and elimination. Much simpler, as I said in the introduction there, a lot more just subtraction and multiplication. So let's go ahead and take a look at the first example here. First example says 4x plus 6y equals 3 and 8x minus 3y equals 1. Alright, so again, first step here said we want to make sure we have these in standard form. Well, notice both of these are in standard form. We have x terms first, then y terms, then equal signs, then plain Jane numbers. So we've got that. I'm going to go ahead and set up two fractions for ourselves. One for x and one for y, and these fractions are going to have matrices in both the numerator and the denominator. And again, a matrix is just an array of numbers. That's all it is. It's just a bunch of numbers put together in some type of pattern here. Not a big deal. Now, what the question prescribes you do first is you fill in the matrices in the denominators. And the way you do that is you use the coefficients. The coefficients are the numbers in front of the variables. So if we take a look here, in front of this x on top, we have a 4. In front of this y on top, we have a 6. In front of this x on the bottom here, we have an 8. and in front of this y here on the bottom we've got with the sign -3. So that's the numbers we're going to fill in the matrix in the denominator, both of them. And we're going to put them in the exact same order they show up there. So since 4 is in the upper left, when I write this, I'm going to write 4 in the upper left of my matrix. 6 is in the upper right of this set of numbers here, so I'm going to write that in the upper right side of my matrix. 8 is in the lower left, so I'm going to put 8 in the lower left. And -3 is in the bottom right, so I'm going to write it in the bottom right. And the y matrix denominator, it's the exact same thing, so that's really easy. And that's always going to be true. These denominators, they're always going to be the same. Okay, so now we got to fill in the ones on the top. Now that's where some steps go into play here. If you take a look at step 4, it tells you where to go now. What you're supposed to do for the right row on X, right there, and the left row on Y, right there, is you just lift up whatever's right beneath it and write it again. So I've got 6 and -3, and I've got 4 and 8. And that'll take care of step 4. Now, step 5 says in the remaining spots, what I'm supposed to do is write the matrix of coefficients. The matrix of, not the matrix of coefficients, but the solution matrix. The solution matrix, well, think about what does solution mean to you. Hopefully it means equals. Equals is what comes after the equal sign. So that's going to be my 3 here and my 1 here. That's going to be my solution matrix. And that's what I'm going to write here in these remaining spots. And it's the same thing on the left side as it is here on the right side. And you're going to write it again in the exact same order it appears. So since 3 is on the top and 1 is on the bottom, I'm going to write 3 on the top and 1 on the bottom. Same thing over here. Alright, now you may not be seeing it yet, but here we go. Here's what the next step says. Now it says to take or find the determinant of the matrices. To do that, you're going to multiply down the main diagonal, multiply down the backwards diagonal, and then subtract the results. We're going to have to do this 4 times, but of course since these guys are the same down here, it's actually going to be the same thing. So look, here's what it's telling you to do. Multiply down the main diagonal. 4 times -3. That's -12. Then you're going to multiply down the backwards diagonal. You've got 6 times 8, 48. Directions say subtract those two. Alright, well, we'll do that in a second. Let's go ahead and do all the other parts here, all the other matrices. I've got 3 times -3, -9. 6 times 1, 6. Come over here. Well, this one on the bottom, as I already told you, is exactly the same. -12 minus 48. Same as the other denominator. Again, we already wrote that these are the same. Alright, up top here, we've got 4 times 1, which is 4. 3 times 8, which is 24. Now, you might be confused with process because we've gone through a lot of steps here. But what you certainly aren't confused by is the math here. Alright, think about what we've done so far. We've written multiplication, or we found products, we've done multiplication problems, and then we stuck subtraction signs in between those results. There's nothing there that you can't do. Multiplication and subtraction, big deal. Alright, so let's simplify these guys here. We've got -9 minus 6, that's -15, over -12 minus 48, just -60. You know the denominator over here is the same, -60. Top up here, 4 minus 24, that's -20. So now we just got to finish this here, and that's how I'm going to find x and y is by dividing. So most of you are probably going to do -15 divided by -60 here and change this into a fourth, or 0.25. Here you've got -20 divided by -60, which is a third, or 0.3 repeating. And now we found our solution. X is 0.25 and y is 0.3 repeating. That's the value that when I plug it in for x and y in both equations at the same time, that the left side is going to equal the right side. If we want to think about this in terms of how we would have solved this by graphing, that's the point. If I graph both of these equations, that the two graphs would overlap. Okay, and again, as we look at what we did here at the end, again, there's no math you can't handle there. We divided. Big deal. We've done subtraction, we've done multiplication, we've done division. That's all mathematical processes of which you're very familiar by now. All right, so let's try this again here. Here's question number 2. Question number 2 says 4x minus 3y equals negative 14, and 3x minus 5y equals negative 5. All right, so we want to make sure they're in order, and as you can see here, we've got x's first, then y's, then equal signs, then numbers. So that's perfect, because that's the exact order we're supposed to have these guys in, so that's good. So we've taken care of step 1 in the how-to here. All right, so the next thing I'm supposed to do is I'm going to set up some matrices here, 2 fractions with matrices in both the numerator and the denominator. All right, directions here tell me to fill in the denominators first. And for the denominators, again, I use the matrix of coefficients. That's the things that are in front of my variables. And I'm going to use those in the exact same order that they appear in the question. So if I look at this question, I've got 4 in the upper left, negative 3 in the upper right corner, 3 in the lower left corner, and negative 5 in the lower right corner. And again, this guy over here is going to be exactly the same. Okay, next set of steps here says we're going to start filling in the numerators now. And what we're going to do is fill in the inside terms. On the x's, we lift up what's in the right row and just rewrite it. And for y's, we write down what's in the left row. Just rewrite it. So I've got negative 3 and negative 5 transferring over, and I've got 4 and 3 transferring over. All right, and we're almost there, done filling in. The only thing I've got left here are the remaining spots for x and y, and again, that is the solution matrix. Solution, the stuff that's after the equal sign here. So that's going to be my negative 14 and my negative 5. That's what I'm going to write in my remaining blank spots. And again, I'm going to write them in the exact order they appear. So since negative 14 is on top, it's going to stay on the top. Negative 15 is in the denominator. It's going to stay in the denominator. All right, so now that I filled these guys all in, these matrices, these 2 by 2 matrices, I find the determinants. The determinant says multiply down the main diagonal, multiply down the backwards diagonal, and put subtraction between the two. No big deal. So I've got negative 14 times negative 5. Well, that's going to give me positive 70. And then negative 3 and negative 5 is going to give me positive 15. And again, I'm putting subtraction in between. Denominators, 4 times negative 5 is negative 20. And negative 3 times 3 is negative 9. And again, subtraction in between. Denominator over here is exactly the same, just as you saw in the previous question. Why? Because these are the same matrices. And the top here, we've got 4 times negative 5, which is negative 20. And negative 14 times 3, which is negative 42. And I'm going to put a subtraction in between. All right, now as you can see here, in 3 instances, the whole fraction on the right and the bottom left there, I've got minus a negative. As you already know, minus a negative changes into plus. So let's fix all those minus and negatives up, and then we'll be ready to rock and roll and do some what is now addition and some division. And some subtraction still. All right, so I've got 70 minus 15 there. It's 55. Over negative 20 plus 9, that's negative 11. Over here, again, the denominator is the same, but the numerator up here is negative 20 plus 42, 22. Now, you're probably sitting there going for a while, ooh, these numbers don't look very good. Well, look how it worked out now. All right, find x. 55 divided by negative 11. negative 5. Find y. 22 divided by negative 11, negative 2. And we found our solution, negative 5, comma, negative 2. If I change x into negative 5 and y into negative 2, the left side will equal the right side in the equation. All right, let's continue on with the notes here. We're going to go ahead and take a look at question number 3 now. Question number 3, we've got 3x plus 4y equals 19 and 2x minus y equals 9. Now, as you can see, these are written in standard form, x, y is equal signs numbers, so we don't have to worry about that. The one thing that may be an issue here, or might become an issue if we don't address it, y here in the bottom equation has no number in front of it. As you already know by now, if it doesn't have a number in front of it, it's like there's a 1 in front of it. So we're going to treat that like 1y, and indeed we'll end up treating it like negative 1y actually, because there's a minus in front of it. Alright, so we've taken care of step 1, making sure we have standard form, x, y is equal signs numbers. So let's go ahead now and set up some fractions with matrices. All right, we're going to start with the denominator here. Again, the denominators here are the matrix of coefficients. So those are the numbers that are in front of my variables. And we're going to write them in the exact same order that you see them in the question. So we've got 3 and 4 and 2 and negative 1. It says 3 is in the upper left. I'm going to write them in the upper left. 4 is in the upper right of what I've highlighted. So I'm going to put them in the upper right. 2 is in the lower left of what I've highlighted, so I'm going to write it in the lower left of both matrices. And negative 1 is in the bottom right of what I've highlighted, so I'm going to write that in the bottom right of the matrix. All right, solution now says I'm going to take what's on the inside and fill in the numerators by just lifting those up. That's all I have to do. And as you've caught on by now, it hasn't changed from question 1 and 2. That process doesn't change any point. It's not going to flip to the outsides. It's always the inside terms that I'm lifting up. So I've got 4 and negative 1 and 3 and 2. All right, so what's left now is for me to fill in the remaining spots. And again, I fill in the remaining spots with the solution matrix, which is, again, think of solution. Solution is what it equals. It's the stuff that's after the equal sign. So that's my 19 and my 9. And that's what I'm going to put in the remaining spots for x and y in the exact order they appear. 19 on top, 9 on the bottom. Alright, so now I'm going to go ahead and start solving. And again, I have to find the determinant. The determinant says I multiply down the main diagonal of the matrix, then down the backwards diagonal. So start up here with x in the numerator. 19 times negative 1 is negative 19, and 4 times 9 is 36. Denominators, 3 times negative 1 is negative 3, 4 times 2 is 8. And again, I'm always putting subtraction signs between my products. Denominator over here is exactly the same. Again, it always will be, because this is always going to be the same matrix for x and y. All right, come back over here to the numerators for y. 3 times 9 is 27, and 19 times 2 is 38. And now that we've done that, now we can go ahead and take care of some solving here. So the top here on x, negative 19 minus 36, that's negative 55. Doesn't look good, but look at the bottom, negative 3 minus 8, negative 11. Well, negative 55 divided by negative 11 is 5, so we've now found that x is 5. Over here, I've got 27 minus 38, which is negative 11, over my denominator, which is the same as the other one, negative 11. Divide that out, and I get 1. So I know if I change x into 5 and y into 1 in both equations at the same time, the left side will end up equaling the right side. Neat. Again, as you can see, we're not doing a lot of that solving equation process. We're just sticking with some basic operations here in solving. Some different things we've never seen before, but it's really just a lot of subtraction and multiplication and division. Not a big deal. All right, let's try one more that's set up, and then we're going to struggle a little bit and take a look at one that's not really set up. So we're taking a look at number 4 here. We've got 3x plus 2y equals negative 2, and we've got 2x plus 5y equals negative 5. So first thing we see here is that these are in order of standard form, x, y's, equal signs, and numbers. So they've taken care of the tough stuff for us. All right, so as you can see, while I've talked about that, I'm going ahead and setting up what the next step tells us. Two fractions with matrices in both the numerators and denominators. And we'll start off as the directions say to do next, and start off by filling in the denominators with the coefficients, the numbers that are in front of my variables. As you can see this time, it's kind of nice. They're all positive. We've got 3, 2, 2, and 5. 3 and 2 in the top, and 2 and 5 in the bottom. And again, I'm going to write them the exact same way they appear in the questions that I've just highlighted there. 3 and 2 are on the top from left to right. 2 and 5 are in the bottom from left to right. And again, we want to point out, as I have every single time, that these two denominator matrices are the same, exactly the same. All right, so now let's fill in what the next step tells us to do, and that would be the right side of x in the numerator and the left side of y in the denominator or the numerator, and that's just me lifting that information up. So since it says 2, 5 down here, I'm going to drag the 2 and 5 up. Since it says 3 and 2 down here, I'm going to drag my 3 and 2 up. All right, so we've only got a couple spots left blank now, and those last few blanks are reserved for the solution matrix, as you've heard me say many, many times. Again, think of solution. Solution equals. It's the stuff that's after the equal sign. All right, and that's negative 2 and negative 5. And again, you got to write it the exact same way it shows up, and that's what's going to go in my remaining blank spots, negative 2 and negative 5. And now it's ready for me to start solving here. Again, I'm finding what they call the determinant of each matrix, which simply means I'm going to multiply down the main diagonal, multiply down the backwards diagonal, and then subtract those two results. So let's start up here on the top for x. Negative 2 times 5, negative 10. And then 2 times negative 5, well, that's another negative 10 with subtraction in between. Let's come down to the denominator here. 3 times 5 is 15. 2 times 2 is going to change into 4. Denominator on the right side is exactly the same because it's the exact same matrix. Numerators, we've got 3 times negative 5, which is negative 15. And negative 2 times 2, which is negative 4. And again, subtraction in between. Well, as you can see, we've got a couple minus and negatives here, both in the numerators here. So we're going to go ahead and fix those up and change those into pluses, and then we are ready to solve. Going to go ahead and do our adding and subtracting and then our dividing. So we've got negative 10 plus 10, which is 0, over 15 minus 4, which is 11. Well, 0 divided by 11 is 0. So x has to equal 0 here. Interesting. Y side, negative 15 plus 4 is negative 11. Over 15 minus 4, which as we already said is 11. Negative 11 divided by 11 is negative 1, which means y has to equal negative 1. So if I change x into 0 and y into negative 1 in both equations at the same time, the left side will equal the right side. We can check it. 3 times 0 is 0, plus 2 times negative 1 is negative 2. 2 times 0 is 0, plus 5 times negative 1 is negative 5. There you go. We've even checked it. The left side does end up equaling the right side. All right, so let's go ahead and take a look at the question we've got left here. The question we have left here is number 5. Number 5, a little bit different, and as you can see, there's even a notation there on the notes, this says pay special attention to the order. These are not in standard form because standard form has x's, then y's, then equal signs, then numbers. Well, as you can see, looking at the equation on the top there, we do have x first, but y is at the very end. It's supposed to be y's after the x's. So we're going to have to fix that. We're going to drag him over to the other side. And same thing here in the bottom equation, negative 3y equals negative 2x plus 5. Well, it's got to be x's and y's on the left side, and y's is the only thing on the left side. So we're going to drag him over to the other side too. Now remember, the way you want to do that is just like solving an equation, but you never actually combine anything. So you're going to do the opposite to move something to the opposite side of the equal sign. Not a big deal there. So let's go ahead and fix these guys up here. We've got x equals 1 minus 2y. I'm going to add the 2y's to both sides. And I'll end up with x plus 2y equals 1. And I fixed the top equation. And in the bottom equation, I've got negative 3y equals negative 2x plus 5. And again, knowing I got to move that negative 2x, I'm going to do the opposite, which is me adding 2x to both sides. So I've got 2x minus 3y equals 5. And now I've got a system of equations I can work with here because they're both in standard form. Now some of you might be wondering, why didn't I write it exactly like this? Why didn't I write negative 3y plus 2x? Well, realize there's nothing wrong with that, but the problem is if I write it that way, I'm going to have y first and then x second. Standard form has x first and then y second. So if I write it this way, just as it shows up here, I'm going to have to do another step of work to fix it to put it in the correct form. So in essence, I'm just saving you a step of work. By all means, if you want to write negative 3y plus 2x equals 5 and then end up flipping it manually and doing that extra step, you're more than welcome to. Alright, but this guy here, this set right there, that I just kind of put those wavy braces around, that's where I'm going to go here. That's the set I'm going to use to set up my matrices. Now, once again, do have a little bit of an issue here like we saw earlier. There is no number in front of x. If there's no number there, you want to put a number there. So we're going to go ahead and fill in a 1. And now I have my matrix of coefficients because I have numbers in front of all the variables. So let's go ahead and set up some matrices. 2 by 2 matrices, numerator and denominator. Alright, the denominator is where we start, and again we're using the numbers that are in front of my variables with their signs. So we've got 1 and 2 in the top row, 1 in front of x, 2 in front of y. Both denominators are the same, remember, so I'm writing it on both the left and the right side. And the bottom row there is 2 and negative 3, again with the signs. Since that 3 is minus in front of it, I'm writing it like it's negative. Alright, now let's look at filling in the numerators here. As we look at filling in the numerators, again, the stuff on the inside just lifts up, and that's how we'll fill in half of each of those matrices. So 2 and negative 3 lift up on the left, and 1 and 2 lift up on the right. Again, notice here I'm lifting the inside every time. Every single time I've done that. In every single question we've solved today, I always end up lifting what's on the inside. You don't have to think, am I lifting up the outside? Am I lifting up the inside? What am I doing here? You're always lifting up the inside. Remaining blank spots, that's again what we call the solution matrix. That's the stuff that's after the equal sign. So that's my 1 and my 5. And now we'll go ahead and look at solving what we've got here. Again, to do that, we're going to multiply down the main diagonal, then multiply down the backwards diagonal, and then solve. So let's go here. We've got 1 and negative 3, and 2 and 5, which is 10. Down here in the bottom, we've got 1 and negative 3 again, negative 3, 2 and 2, which is 4. Same denominator over here, but the numerator is going to be a little bit different. Got 1 and 5 here, which is going to change into 5. And 1 and 2 here, which is going to change into 2. Alright, so got all that figured out. Again, subtraction signs between everything. No minus and negatives here, so we can just jump into solving. So over here, I've got negative 13 over negative 7. Interesting. And over here, I've got 7 over negative 7. Now, some of you are looking at this going, oh boy, this guy, I don't know about that. What am I going to do there? You're not going to do anything there. You're going to leave it exactly what it says. If it says negative 13 over negative 7, my solution is going to be 13 sevenths. The only reason I'm writing 13 sevenths instead of the negatives is because negative divided by a negative is a positive. For y, much easier. 7 divided by negative 7, negative 1. So if I change x into 13 sevenths and y into negative 1, I've got my solution to my system of equations.